Please title these notes Integrals 3 Notes, Signed Area, and write today's date. By the end of this lesson, you should be able to estimate the area under a curve when the area is negative as well as positive. Unlike in geometry, it is entirely possible to have negative area in calculus. Basically, it's like this. Say we have some function going like that. Any area above the x-axis is positive. Any area below the x-axis is negative. It does not matter which side of the y-axis the area is on, only which side of the x-axis. Let's write that. Area above the x-axis has a positive signed area. Area below the x-axis has a negative signed area. Which side of the y-axis the area is on doesn't matter. Let's look at an example. Approximate the integral from -4 to 4 of x with respect to x using left Riemann sums with width 2. So the first thing is to realize that the equation y equals x is just a straight line like that. 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, and so on. 1, 2, 3, 4, 5, 2, 3, 4, 5. So we're going from -4 to 4 with 2. And we're using left Riemann sums, so that means that we're going to take the left side, go and touch the line, then draw over until we come to our next one. Notice if we're going down to touch the line, that's the same thing. We're still touching that left corner for the left Riemann sum, even if we had to go down to do it. So for our next, we're going to take the left side, touch the line, and then draw across. Here we're going to take the left side. Notice that the left side is actually on the 0 mark. So y equals 0. Touching it right now, I don't have to go anywhere. I'm still going to draw my rectangle over. My rectangle has 0 width, but that's okay. Then here, this is more normal. We're on the left side of this interval. We go up, we touch, and we draw over to the right side. Now we want to find the height for each of these. It's just y equals x. So whatever the x-coordinate is, that's the y-coordinate here. So this is -4. This right here, -2 high. This right here is 0 high. This right here is 2 high. So the integral from -4 to 4 x dx approximately equals, this width right here is 2, this height is -4, and here it's the same thing, it's just height times width times height, I should say, and if the height happens to be negative, height's negative, so what? This also has a width of 2 and a height of -2. This little flat one right here, it also has a width of 2, it has a height of 0, that's okay. This one has a height of 2, width of positive 2. So we just add this up, -8, -4, 0, 4. The area is approximately -8. So, check for understanding. Estimate the integral from -2 to 3 of -x squared dx using trapezoidal Riemann sums with intervals of width 1. Okay, try that on your own and restart the video when you're ready. Pause the video now. Okay, here's what I got. So I sketched my curve. I said we're going from -2 to 3 with intervals of width 1. So since I'm using a trapezoidal sum, I drew each line down, in this case, to the curve, since these are going by 1. And then I connected those to make that little trapezoid. And then I used this formula to find the height of each of the lines that I drew. So -2 squared times a negative is -4, and so on. And then for the trapezoidal sum, we have to find the average height for each trapezoid. So right here, I took this height plus this height, divided them by 2, and then multiplied times 1, which is the width. So I got this -5/2. I did the same thing for each of the other 4 trapezoids. Then when I added up that height, I got -25/2, or -12.5. Our final piece, we're going to talk about estimating from a table. Sometimes you're going to get things that look like this. So using the subintervals indicated by the table below, which we haven't drawn yet, estimate the integral from 2 to 11 of f of x dx. So we're going to have a little table. There's x, there's f of x. So we're given just some specific points. When x is 2, f of x is 3. When x is 5, f of x is 6. When x is 6, f of x is -3. When x is 11, f of x is 2, and when x is 15, f of x is 5. One of the things to be really, really aware of with the table, the widths do not have to be the same. Notice that from 2 to 5, we go over 3, but from 5 to 6 we only go over 1. So the first thing that you're going to do is plot the table. So we don't know anything that's happening aside from these points, but we can at least sketch them. So let's say the highest I'm going to go is 6. So 1, 2, 3, 4, 5, 6. I can go all the way over to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I'm going to have to go down. -3 is right there. So When x is 2, f of x is 3. I'll put a nice dot right there. When x is 5, f of x is 6. When x is 6, f of x is negative 3. At 11, there's a big jump, and this is 2. And notice right here, we are going from 2 to 11. We have extra information right here that we don't need. It's going to be very tempting to just draw everything that you're told and then go all the way to the end. But this is the thing to watch out for. Oh, there's a piece that I forgot to put in this. Estimate this integral using trapezoidal sums. Okay, so we have the intervals here. We're going to be going from 2 to 5, from 5 to 6, just because that's what we have, and from 6 to 11. So for the trapezoids, we're just going to draw our trapezoids in just like we did before. So we come up to here, we just connect them in a trapezoid. So it's going to go down to there, so we're going to have this weird funky trapezoid right there. And then this is going to come up to here, so we're going to have another weirdo funky trapezoid right there. We're going to do the exact same thing that we did with the one above to estimate the integral from 2 to 11 of f of x dx. We're just going to find each of these heights, which is given to us right here in the table. And we're just going to find the average height for each trapezoid. So this one, this is the point 2, 3. This is the point 5, 6. This is the point 6, negative 3. 11, 2. So to find this average height here, so if you want to, you can mark this right here. This height is 3. This height is 6. This height is negative 3. This height is 2. So average height, 3 plus 6, divided by 2, times the width, which is 1, 2, 3. And then for our next one, the average height is going to be 6 plus negative 3 over 2 times the width, which is 1. Make sure, if these are different widths, you have different numbers here. Normally they're the same when we have these types of problems. With tables in particular, they don't have to be the same width. And then for this final trapezoid, height negative 3 plus 2, that's our average height. And then the width was 1, 2, 3, 4, 5. So when we go and find these, we have 4.5 times 3 plus 1.5 times 1 plus negative 0.5 times 5. And when we add those all together, we should get 12.5. This concludes Integrals 2 notes.